Hello everyone, my name is Eric Ratomero. I am a systems analyst in the research IT department at the Jackson Laboratory, which is a research nonprofit that's based in Bar Harbor, Maine, United States. I work in a group called Imaging Solutions, and we provide hardware and software support for 70 to 80 PIs and their groups on all their needs when it comes to imaging data. So first of all, I want to thank you all for the interest in this workshop. I will go through a very short presentation on what ezomero is, describe a little bit of how it works, then I will show you some concrete examples of how ezomero works in action. So if you have not gone through our setup guide, which is in the GitHub repository for this workshop, this is a very good time to do that. So pause the video and go through the setup guide. I tried to do a good job at describing all possible scenarios you might be finding yourself in and how to set up everything so that you can go through this workshop. I encourage everyone to follow along on the stuff I'm doing, actually writing the commands I'm going to be writing, seeing the results on your computer. To do that, you are going to need a Python environment that has ezomero, and you will need access to an OMERO server. So the setup guide goes into detail on how to get these things together. Okay, so I'm going to introduce you very quickly to ezomero, which is a library that we have created to make Python code that talks to OMERO in a simpler and cleaner way, basically. So if you have not heard about OMERO before, OMERO is a data management platform that is geared towards microscopy data. It uses a client-server framework. So you have your OMERO server that talks to different kinds of clients through a network. It uses the powerful bioformats library to provide functionality from a secure central repository. It makes it pretty easy to view, organize, analyze, share your data from wherever you have an internet connection, basically. So sometimes the out-of-the-box functionality of OMERO is not quite everything that you need. So if you want to do some advanced viewing, advanced management, or analysis of your data, and that's when Python comes to the rescue. So the OME team provides a robust Python API to interact with an OMERO server. It's very powerful. It can be hard to use if you're starting out, and it can be pretty verbose. So in this example here, we're creating a new annotation attached to a project, and it takes 11 lines of code and a lot of stuff using the default API. And with our ezomero API, it's significantly simplified. So over time, we ended up with lots of those small convenience functions to do common tasks. So we bundled them all together. We released them as a Python library, which is ezomero. You just need to do pip install ezomero, and then you import ezomero in your code, and you're good to go. In addition to this workshop, we also have a poster with information on the functionality of ezomero. If you would like to see something that is not there yet, we welcome new issues, new pull requests on our GitHub repository. The address is down here. Since making ezomero available, we have already had contributions from outside our group multiple times, both in terms of suggesting new features and implementing them. We have released ezomero 1.0 earlier this year. You can see here we are at 1.01. It includes new features such as regions of interest and retrieving images at multiple pyramid levels. So we look forward to getting more people to use it. This is just a very quick preview of what we are actually talking about in this workshop. Now I will go through some of the main features in a bit more detail. Okay, so before we start the actual workshop, I will go through a very simple example on how to retrieve an image from an OMERO server using OMERO and ezomero just as a warm-up and a point of comparison. This is just a teaser of the things we're going to be doing, just to show that it's real easy to do stuff with the scaffolding that we have built here. Besides the two APIs that we are showing here, which are ezomero and the default OMERO Python API, OMERO has a command line interface that can do a lot of stuff. almost all of it you can do with the OMERO Python API anyway, so it's kind of redundant to show it here. It's useful if you just want to write kind of like a bash script to automate something, but we're not going to go into that here. Okay, so first things first, the thing I normally use for storing the parameters of my connection to OMERO is a file that I generally call config.py. I'll show what it looks like for this workshop here. So this is just like, what is my username and my password, my host name, and the port I'm going to connect to, and so on. So all this sensitive information is here. When I'm working with this on a GitHub repository, for example, I normally have it as a local file that is added to my git ignore, so it's not uploaded to GitHub itself. I make sure it's accessible only for the user I'm using, and I don't keep it saved between sessions or keep it saved without the password. So it's very convenient to work with this, but it's something you should keep in mind in terms of security. So don't store your password in a regular text file that people have access to, is essentially what I'm saying. In this case here, I am going to be running this on a local server that is running out of Docker, so I have no reason not to show you this because it's irrelevant. If you're using the Docker Compose that is in the GitHub repository for the workshop, you can use this file just as it is here. Otherwise, you need to make sure that you change this file to your OMERO connection parameters. Okay, so what I'm going to do first is I'm going to copy this file to the main folder here. Copy. Paste. There we go. Just so I have access to it from any notebook I start here. So, right. So the first thing I'm going to do is everything I'm doing here is going to be running on the Docker Compose that I have added to the GitHub repository for the workshop. So the Jupyter Lab that you see here is just running out of that Docker Compose. The OMERO server that you see here is also just running out of that. So I just followed what is on the setup guide, and these are the things I got. So if you're also using that, you are going to be seeing exactly the same things I'm seeing here. So I'm going to start a notebook on the workshop environment here. Okay, so the first thing I'm going to do is I'm going to import those config things. So I'm going to import OMERO user, OMERO pass, OMERO host, OMERO port, I think. I think that's all I need. Yeah. So if you're not familiar with Jupyter Notebooks, you can press Shift Enter to run that cell. And in this case, it's good to run this just to see that it actually succeeded in importing all your stuff there. Okay, so the first thing we are going to do after this is just importing some libraries and then defining which image ID we are actually going to be retrieving. So if you do not have any data on your OMERO server, as I don't on mine here, you see it's completely empty. If you don't have any data there, this is a good time to stop the video and import some data into your OMERO server before you do that. The setup guide has some instructions on how to use OMERO Insight to upload that data. It's also available on the OMERO documentation. It's a pretty easy process. So I'm going to give you a minute here to make sure that you have at least one image in your OMERO server and that you have the ID for that image. And I am also going to import some data into this server. Okay, so now I have an image in my server here. You see the image ID is 101. It might be different for you, but in my case here, image ID is 101. If you want to look at the image, you can double click it and you should see, in my case here, a beautiful photo of Bar Harbor, Maine, which is where the Jackson Laboratory is located. The important thing here is getting this image ID. So in my case, it's going to be 101. So what we're going to do next is we're going to import ezomero. We are going to import matplotlib, pyplot, splt, as most people who work with any data stuff have done in the past. And I'm going to create a variable image ID. which is my image ID. So it's 101. It's good to run this cell as well, just to make sure that your imports have gone through just fine and everything is working as intended. If you get an error here saying you don't have ezomero, make sure that here on the top right, your kernel that you were executing is actually workshop, because only the workshop kernel actually has ezomero in there. Okay, so I'm just going to add some magic here to make matplotlib plot things the correct way, the way I want to. So I'm going to do matplotlib inline, and I'm going to do config inline backend figure format is retina. So it's just to make sure that it's plotting things the way I want them to. Some formatting and stuff. Okay. So the first step we need to do to talk to an OMERO server is creating a connection to that server. So we are just going to create a connection object using ezomero and the parameters that we have imported here from the config file. So I'm going to do connection is ezomero.connect, and I'm going to use OMERO user, OMERO pass. Then there is an empty string here that just says use the default group for that user. Instead, you could, if your user were in multiple groups, you could pass which group you want to connect to here. Then there is host, ezomero host, port, ezomero port, and I want my connection to be secure. Okay, if you run this and you don't get an error, you have a connection to the OMERO server. So your con object here is now an active, valid connection to the server. I'm not going to go into detail about ezomero connect just right now, but there are multiple ways you could be doing this. In this case here, we're just passing each individual argument to the connection. You could also store these in environment variables. You could also store these in a .ezomero file that just has the variables there. But in this case, we're just passing the arguments there. Okay, so this connection object that we have generated here is the thing we are going to be passing to every ezomero function. So every ezomero function, the first argument is always your open valid connection. And then there will be different arguments depending on which function you are using. So we are going to be using the function getImage to get an image, as you would expect. The getImage function takes a connection object, it takes an image ID, and we are going to specify an optional argument saying that we want the dimensions to be ordered in a specific way. So ezomero.getImage, I'm going to start typing it here. ezomero.getImage always returns a 5-dimensional NumPy array. So different from a regular getImage from the regular OMERO API that would just give you kind of like an image object thing. This actually gives you a NumPy array that you can just use. And I want this to be true. So I'm specifying that I want this specific order of dimensions. So it's going to be X, Y, Z, C, T. So we can print the shape of these pixels here. So you see that getImage is returning two things here. It's returning an array with the pixels themselves, and it's also returning an image object that you can use just like a regular image object on the default OMERO API. So if I just do this, you see that it returned the image I had there that has 3 channels, which is RGB. It has 1 Z-slice, 1 time point, and it is a 4K image. Now we can plot it in show, and it's going to be pixel. And in this case here, I'm going to plot just the red component of this image here, just for simplicity. So I'm going to get everything from X, everything from Y, and then 0, 0, 0. And actually, because of the ordering of the dimensions here versus what they are versus what matplotlib wants here, you actually need to transpose this image to make it look right. So I can do that. And you see that this is the red component of my image there in OMERO. And now here, I'm going to close the connection. That's all. That's all I wanted to do. I just wanted to see the image. So that's the easy OMERO way to do this. So you create a connection object in one line, you get one line to retrieve the pixels, and then you have one line to plot the pixels, and that's all. Now we are going to be doing the same thing using the default OMERO Python API. And you will see that it's a little bit more involved. There's a little bit more work. The code is slightly less legible. And I should emphasize here that this is not me saying the default Python API is bad or anything like that. It is super powerful, and under the hood, EasyOMERO is just using the default Python API. So it is excellent stuff. It's just kind of difficult to use if you're starting out. So that's essentially the niche we're trying to fill in here. So to do that using the default OMERO API, the first thing we need to do is we need to import a specific class from OMERO Gateway, which is the Blitz Gateway class. And this is going to be our connection object. Then we need to create it. So we need to instantiate this class. It's going to be Blitz Gateway, and I'm also going to be using OMERO user, OMERO pass, port is OMERO port. And what am I missing here? Host is OMERO host. Okay. Okay, so this is not enough to create a connection though. So we actually need to, I'm just going to capture the return value here. We actually need to tell this object to connect. So the first line is just instantiating this class here. Second line is actually connecting it. And here I'm just going to print the return value just to make sure that I'm actually getting true for the connection. And I didn't. That's because I forgot to say that I want a secure connection. There we go. So now I got a true value. Okay, so true is good. True is what you want here. Okay. Then for this specific case where we just have a single plane image, it's not too bad to use the default OMERO Python API because it has a getPlane function that would retrieve a single plane. But of course, if you wanted a full 5D array with multiple channels and Z slices and time points, you can see that all of a sudden it becomes much harder because you need to like iterate to retrieve a bunch of planes, loop over a bunch of stuff. It gets more complicated. But in this case here, the first thing we're going to do is we're going to get the image object. So that's the same thing that EasyOMERO is returning here as img. But here I'm going to do that again just for completeness. So I need to use the getObject function from this class here, and I need to say I want an image, and I want the image with image ID that I specified. Then I actually need to get the pixels from that image, and that is just image.get primary pixels. And then after that, I need to specify which plane I actually want. So then I can do pixels.getPlane. And in this case, I want Z0, C0, T0. And then finally, I can do the plotting. And you see, of course, I get the same thing. It's, yeah. You see that what took us basically 3 lines to do here, it's going to, I'm going to ignore the importing here, but it takes like 1, 2, 3, 4, 5, 6 lines to do here. So it's twice as much code. And of course, in this case, it's between 3 and 6 lines, but if you're doing something bigger, all of a sudden, and this was the simplest case where you just want a single plane. Finally, don't forget to close your connection. Okay, so that was just a very quick teaser introduction to show this is what EasyOMERO looks like in a very general sense. And this is what you would be doing with the default Python interface if you're not using EasyOMERO. So now I'm actually going to go through a little bit more functionality that EasyOMERO offers. And I'm not going to be doing points of comparison with the default Python API, but in general, it's it's always going to be simpler. And one thing we also try to do is always have inputs and outputs be things that you are going to be using elsewhere. So NumPy arrays instead of just image objects. So in this case here, the only time you actually get a NumPy array is all the way when you get the plane. So we just wanted to get the actual data as fast as possible. So yeah, next step is we are going to be looking at how OMERO creates things in a server. If you want to take a break, this is a good time for it before we start a new part of this. Okay, it's time to dig into OMERO itself. Before I go on, I just want to remind again that OMERO is just using the default OMERO Python API under the hood, and that API in turn uses a thing called ICE, which is a specific framework to talk directly to the server itself and not the web interface you see here. So the web interface is also just a client that is talking to the OMERO server. I just wanted to make that distinction clear here. Okay, so the beginning of this is pretty familiar. We are going to import our config stuff and matplotlib and ezomero. I don't think we need matplotlib for this. I'm going to import it anyway, just in case. So I'm going to import my parameters again. I'm going to, just in case I need it, and I'm going to import ezomero. Okay, I forgot import. Okay, again, first step is pretty familiar. We are just going to create a connection object. So I'm going to be using OMERO user, OMERO pass. I'm going to use that empty string again for default group. Host is OMERO host. Port is OMERO port, and secure is true. Okay, so as I mentioned before, there are a few extra options for OMERO Connect in case you don't want to be passing every single thing every single time you're creating a new connection. You can set environmental variables such as like OMERO user, I think, and OMERO pass and stuff like that. And OMERO will automatically pick those environment variables up to use here. There, you can also create a hidden file named .ezomero with your connection parameters. Those are also going to be used automatically if they're. So the function will always use whatever you pass here as priority number 1. Then it's going to check the environment variables. Then it's going to check the .ezomero file. And finally, if anything is still missing, it's going to ask you for that. So if I didn't put username and password here, or if I just didn't put the password, it would actually prompt me for a password. So it's going to ask you directly for the things that are still missing. Okay, so the first thing I want to note here, did I run this? I think I ran this, but let's run it again just in case. One thing I want to note here is that OMERO is fully compatible with the regular OMERO Python API. So this object that you're generating here is literally just one of those Blitz gateway objects that I just showed you for the default Python API. So you can, for example, do ezomero.connect, get this object, and then use this object on default OMERO Python API code, and it's going to work just fine. There's nothing unique about this thing here. So in this case here, I'm just going to write some default Python API code using this connection object just to show that actually it works. So I'm going to get the current user. I'm just going to print it, user.getID, and it's probably just going to be 0 because there is only one user here. I can do print is admin and use a function to check if the current connection is an admin connection. It is, because we only have one user. That user is admin. And I could, for example, do, if you are a member of multiple groups, you could get groups member of, for example, and I could, for example, print name of each group this user is a part of. In this case, there is only one group, it's called system. But if you were to go into the admin interface here, add new groups, add this user to multiple groups, for example, you would see the results here. So you see that here in this whole section, I have used nothing specific from ezomero. It's just things that are default on the OMERO Python API. I'm using the connection object I got from ezomero to just write code that interacts just fine with the default Python API. So if you have code that already does Python stuff talking to OMERO, you can just plug this in on the parts that you are interested in. Okay. From now on, I would recommend having a tab with your Jupyter notebook here, where you will be typing the commands, and the second tab with your OMERO web interface here. So for the Jupyter notebook, you probably got the address from your Docker logs as instructed in the setup guide. For the OMERO web interface, I'm actually going to log out so I can show you again. So you go to localhost 580, and you get this thing here, and the username is root and the password is OMERO, as you could see here on the config file. It's the same username and password, and you can just log in and you get a web interface for your OMERO server. So I would recommend having one tab with your code, one tab on the web interface so you can see what's happening. One other thing I'm going to add is that at any point, if you need to pause and explore what's going on, that's encouraged. Taking it slow is very much encouraged here. That's part of why I made this pre-recorded workshop, so that you could pause at any moment and explore things and try things out. And you should never feel like you are falling behind. Just pause it. If you have any questions, take note of which questions you have, so that when we have a Q&A session, you can ask those questions, and just take it slow. That's my recommendation for this workshop. Okay, so now we are going to start creating things using ezomero. So the first thing we are going to do is we are going to create a little bit of hierarchy. So if you're not super familiar with OMERO, there are two levels of hierarchy you can create here. You can create projects and datasets, and then you can have images inside these datasets. So the first thing I'm going to do is create a new project and a new dataset, so we can put images in a more organized way. So I'm going to do ezomero.post project. So we've tried to follow this kind of like get, post, put architecture for ezomero. So things that are creating new things are called post. Things that are just getting things that already exist are normally get, and put tends to change a thing that already exists. So here you see that things I needed for creating a new project are a connection object, a name for your project, and a project description. The description I think is optional if I'm not mistaken, but you do need a name for it. And as you can expect, what you will get back is a project ID. So in this case here, it created a new project with project ID 101. And if I refresh my web interface here, you'll see that there is a my new project here with ID 101 and the description we gave there. Okay, now we are going to create a data set inside this project. So I'm going to do data ID is ezomero dot, and as you expect, post data set. So this is going to have connection. I'm going to give it a name. I'm not going to give it a description this time, but I will give it a project ID, so that it is created inside that project. And I can also print the dataset ID here, just so we can double check. See, this is dataset 102. And if I refresh this again, you will see that now, if I open this, there's a new dataset there with dataset 102, as we expected. Yeah, so next thing we are going to do is adding an image to that data set. Hopefully you have gone through the import process during the introduction to get an image there, so we could go through the introduction and retrieve that image. What we are going to show now is a different way to create an image in OMERO. It is created directly from a Python script. So you should be warned that the images you create this way that we are going to do right now, they are stored in disk directly as pixel values. So they are not an image file, which is not an issue if you have, for example, like small analysis results. It should be avoided as the main way of adding images to a server. And you will see that when we actually do that, there will be a warning saying, hey, maybe don't do this too much. The import process is way more reliable than what we're going to be doing here. It also captures metadata from a specific file format. In this case here, there's going to be essentially no metadata. It's just going to be the pixels stored in disk. With all that said, we are going to create an image directly here. So the way we're going to do this is I'm going to create a random NumPy array of 8-bit integers with a specific shape. And then we're going to just pass that array to ezomero.postImage as the pixels. And that's all you need to create an image. So first thing I will need is to import NumPy. Then I'm going to actually create the pixels, and I'm going to do random integers with 256 as the highest possible value, because that's an 8-bit integer. And the shape for this, I'm going to pick 200 by 200 by 20 Z slices by 3 channels by 1 time point. Does that make sense? So it's X, Y, Z, C, T. And just in case here, I'm going to make sure that NumPy knows to generate this as 8-bit integers. Okay, size equals that. So if now I were to print pixels, for example, it would just be a 5D matrix of numbers, right? And I probably shouldn't have printed this. It's way too much stuff. But anyway, in fact, let's go back here and remove that. But now, to make that into an actual image in OMERO, I can just do ezomero.postImage. And first, always the connection object. Then you can just give it pixels. You can give it a random image as name, for example. What else? And then I can give it a dataset ID, which is just going to be the dataset I created. And it's just going to put this image into this specific data set. So you see, we get a warning here. Using this function to save images to OMERO is not recommended. Yeah, basically, if you're going to be doing this, talk to your OMERO administrator before doing it. So now, if we refresh this, we see that we have a new image here that's called random image. It has 20 Z slices, 1 time point, 3 channels. And because it has 3 channels, OMERO automatically interprets this as RGB. So we get a colorful rainbow-like static image here. And you might have seen that I unchecked interpolate here, because interpolate just makes everything kind of blurry here. I wanted to see the individual pixels. Also note that we get back the image ID. So this is image 102. Which, here we are. Okay, things to note here. You've seen that I didn't give any dimension ordering here. It assumes that the order is going to be X, Y, Z, C, T. If you have a different dimensional order, you can pass an extra argument called dim order with the specific order of dimensions you want here. The documentation has details on all this stuff. I recommend always checking the documentation. Okay. So that's good. We have created a project, a data set, an image. Now we can add a few annotations to the new things we have created. So in this case here, we are going to add map annotations, and map annotations are just key value pairs to our new project and our new image. There are more things that ezomero can do in terms of adding annotations. In this case here, we're just going to do map annotations as an example. Okay, so obviously we're going to be using a function that is called post map annotation. So post map annotation requires an object type, because a map annotation can be in any kind of object, and you might have seen that Number IDs can be duplicate if they are of different kinds of objects. So you can have a dataset 102 with an image ID 102 inside it. Because they're different kinds of objects, that's not an issue. But because of that, you need to tell ezomero which kind of object you are attaching this to. So you need a kind of object, an object ID, and then the key value pairs for ezomero are just a regular Python dictionary. The final thing is that you will need to give it a namespace, and the namespace can be anything you want. One thing to note is that if you want these annotations to be editable from the OMERO web interface here, they need to have a specific namespace that you need to use. We're not going to be using the specific namespace. I recommend, again, check the documentation if you're interested in that specific thing. We're just going to be using a default, well, not a default, like a namespace I came up with. So the first thing I'm going to do is create two dictionaries here, and these are just regular Python dictionaries with the annotations I want to add to the project and the image. So I'm just adding this first key value pairs that just says test key and test value, and then I'm going to add one that says, is this a project with value? Yes. And this one's going to go to the project. And then I'm going to do a very similar one to be added to the image. But instead of saying, is this a project? Yes, it's going to say, is this a project? No. Okay, then my namespace is just something I picked, and I'm just going to do something like my institution. Did I write this right? Nope. Institution. I know how to spell. My project. Test. It can be anything. Okay, so now we are actually going to post these map annotations to OMERO. So the first one I'm going to do is the project one. So it's going to be easy OMERO to post map annotation. This is going to take the connection object as usual. What kind of object you are attaching this to? So in this case, it's a project, and then it's going to be the ID, and then it's going to be the, let me refresh my memory, it's going to be the dictionary, and then it's going to be the namespace. And if this looks like it's complicated and a lot of code, believe me, it would be way worse if you were doing this with the default OMERO API. So this is going to be image KV dictionary. This is going to be image ID. And I need to tell it that I'm actually adding that to an image. So if I do that, now I can go back to my web interface here, refresh it, and you see that my image now has key value pairs with the namespace that I have established, and it has the two things that I've added to that dictionary. And if I go to my new project, it also has a different key value pair there. Same namespace, but in this case, is this a project, says yes. Okay, so we have created a project, a dataset, an image, and added annotations to that image. The final thing we are not covering right now, we will cover it later, is how to add regions of interest to your image, but that will come later. So of course, don't forget to close your connection when you're done. So these are some of the very basic creation tools you can get with ezomero. There are things that were not covered here. For example, we can create screens and plates. You can add regions of interest, as I mentioned. You can add file annotations, so you can attach a local file to your OMERO image. Yeah, you should take your time to explore the documentation, discover the functionalities by yourself. If you'd like to see something that's not there, feel free to reach out to us, open an issue on GitHub, whatever you prefer. So if you have not taken a break after the last section, this is a very good time to take a break. You can stop here, take 10 minutes to get some water, stretch, come back energized for the next part when we are going to be reading things from OMERO. So yeah, go take a break. I'll see you in a bit. Okay, so now we are going to start looking at the things we have created. So of course, this is just an example. If you already have an OMERO server with more things in there, feel free to look at those things instead of looking at the example things that we're looking at here. So we are going to start with where we ended the introduction section. So retrieving pixels of an image and plotting them. So again, I'm going to plot the first time point, first channel, first slice of a 5D image. And in this case, feel free to pick any image ID that you have on your server. In my case, I have two options, but if you have different server, for example, or if you've put more data there when you were importing images, feel free to pick any image ID you have there. So as usual, we need to make sure we have our imports in place and that we have created a connection. So I'm going to be doing that here. OMERO host, OMERO port. I will import matplotlib because this time we're actually going to use it. I'm going to import ezomero and I'm going to create a connection. OMERO user, OMERO pass, empty string, host is OMERO host, port is OMERO port, pick here is true. Okay. Now I'm going to pick an image ID. And just for variety, I'm going to take my random image here. So I'm going to pick 102. You pick whatever you want. As long as it's an image you have on your server, that's fine. So I'm going to get the image and the pixels here. And we're going to do the same thing we did in the introduction. So I'm going to get image, connection, image ID, XY, ZCT is true. Am I missing anything? I think that's it. Yeah. So I'm going to print the shape of this just so I know I got the right thing. Yep, that looks right. And then I'm going to plot it. And of course, this is just going to look like static because it's a random image. But, you know, at least we know it's the right thing. And the plotting here does some weird stuff in terms of interpolation as well. So it's not going to look as clean as when we were looking at it in OMERO itself. You can see there's a little bit of artifacting stuff going on, but that's fine. We just wanted to make sure we got the right image and that we are actually getting an image, right? So that's cool. But of course, I had to manually tell it the image ID. And if you're writing code, you don't want to be hard coding IDs on your thing. So how do you get the image ID to begin with? So here we are going to start from the top. So the first thing you can do is you can print projects, and then you just need to give it a connection. You see that I have one project. It's just my new project, and the ID is 101. And in general, that's going to be your starting place. So your input to an algorithm or whatever will be a hierarchy level that's normally going to be your project or your data set or whatever. So I'm going to just make project ID to be 101 here, but this is normally the kind of thing that it will be a user input to some degree. So now I can list all the data sets inside this project. And this is the one bit where we don't have good ezomero code for. So if you're interested in contributing, this is a really good first project to get involved because a pretty straightforward thing to do. You'll see that I'm going to do it in like 3 lines, but we don't have get datasets function in ezomero just yet. So if you're interested in contributing, this would be a really good starting place. So here I'll need to do it the OMERO API way. So I need to get object project ID, and then for ds in project dot list children. Oh, I pressed the wrong thing. Print ds.get id. And actually, one more thing I'm going to do here, I'm going to do ds IDs as a list, and I'm going to append this ID to it. Okay, so now you have this list here. In my case, of course, it only has one element because I only have one data set, but you might end up with a list with multiple dataset IDs here if you had multiple datasets. So now we just go one step further. So we are going to pick a dataset that has at least one image in, and we are going to get the IDs for the images. So I could do, for example, image IDs is ezomero.get image IDs, and you pass a connection, and you say dataset is, in my case here, I'm just going to use the first dataset, just like I used the first project thing. Never mind. Yeah, I'm just going to use the first data set here. So if you had multiple data sets on your list here, I'm just going to use the first one. And of course, if you have multiple of them and you want to pick a different one, you can pick a different one. Important thing here is that you need to specify that what you're giving is a data set, but because you can also just give it like a whole project, get all the image IDs for the whole project. So that's also an option in OMERO. And you can do the same thing for a plate or a well, for example. But in this case, we're passing a data set. So we are going to get, again, we only have one image in that data set. So we're going to get a list with a single ID. But that's fine. If you had multiple images, you'll get a list with all the IDs. Okay, so there we go. That's how you would find your image ID by following the hierarchy along until you find the actual ID you are interested in. Okay, so of course you could write code that could very easily loop over all data sets in a project and then do stuff for all the images. You could immediately get all the image IDs for a whole project if you wanted to. So those are pretty easy things to do with ezomero. So one more thing we can do here is we can also look at the annotations in an image. So we can essentially just keep stepping one step further. So in this case here, I'm going to get the annotation IDs that are in an image. So it's going to be ezomero get map annotation IDs, connection as usual. And in this case, again, you need to specify what kind of object you're getting it from, because of IDs that can be the same between different kinds of objects. In this case, I just want it from the first image from image IDs. And if I print that, you will see that we will get one annotation ID here, which is our map annotation that we added to this image. And if you want to see what that map annotation actually is, you can print it with print map annotation. And you can just pass the ID of the map annotation. And you see, you get the ID of the map annotation, the namespace, and the key value pairs that are in there. Okay, there are a few things that I added to the reference notebooks that are on the GitHub repository that I will not cover here. Those are things that relate to groups and users and setting groups and things like that. I encourage you to get familiar with those and look up the documentation and everything. In this case here, because we don't have extra groups and extra users in our server, it's kind of like a silly example to go through, but yeah, ezomero has functions to get group IDs, get user IDs from their names, and importantly, it has a really good function for setting the group of a connection. So if you have a connection that needs to move between groups to do things between two different groups, for example, the function we came up with in ezomero to change between groups is very good, and it solves a lot of the problems we used to have when trying to write code that did things across groups. I should also add that pretty much everything we've seen here, by default, ezomero would do across groups that you have access to. So if you're logged in as a user that has access to multiple groups, and you do, for example, a get image, and you pass an ID that is not in the group that you have logged into, but you have access to, it's going to work just fine. So it's always going to do things in a sane way where it will look across groups that you have access to. So as long as you have a permission to do something, Even if your connection is not in the correct group, it should work. And that's the same for creating things. If you have write access to a group, for example, you can post an image to it, even if your connection object is not in that group specifically at that moment. We try to make it as straightforward as possible. Okay, before we move on to regions of interest, don't forget to close your connection. Okay, so this covers finding IDs and getting things from the server. Next, I'm going to talk about regions of interest, creating and reading regions of interest. But again, this is a good time to have a quick break if you want to have a quick break. And I'll be back in a second talking about ROIs. Okay, the last part of this workshop is working with regions of interest, or ROIs as I'll probably be calling them. These can be kind of difficult to deal with using the default OMERO API, so we kind of engineered ezomero to make it easier to do some of this stuff. I will start by recommending that you create an ROI or two in one of your images in OMERO Web. So using the OMERO Web interface, you can just open one of your images. You can just double click on them. I'm just going to show you how to do it. So you can just double click one of the images here. It should open an OMERO iViewer here. And then you can go to the ROIs tab here on the right. And you can pick any of these drawing tools here and make some ROI. So I'm going to draw a rectangle and I'm going to draw a line. And after you've drawn them, don't forget to save, because otherwise they still don't exist. Okay, so now if I refresh my interface here, you will see that here on the right hand side, it should say ROI count 2, or as many as you have actually drawn. So I ask you to do that because we are going to start by reading ROIs instead of creating, because it's easier this way. Okay. Also, quick explanation on how OMERO deals with ROIs is that there are two separate objects in their data model, one that is called ROI and one that's called shape. So the way it works is that an ROI can contain multiple shapes, which is why there is this differentiation. In our examples, and the things I had just drawn there are just ROIs that have a single shape. So all of our examples will only have one shape per ROI. The things we have drawn here also have one shape per ROI. But because it's possible to have a single ROI with multiple shapes, that's why the distinction will exist in code. So you will see that we are going to get ROI IDs, and then from a single ROI ID, we're going to get shape IDs from that, because you could have multiple shapes in a single ROI. Okay, let's start with the usual imports and connection. At this point, you should be a pro at this. Import is OMERO. And then I'm going to create a connection object. OMERO user. OMERO pass. Empty string. Host is OMERO host. Port is OMERO port. Secure is true. Okay. Now we need to pick an image ID that has ROIs. So in this case here, I drew my ROIs on my random image, which is ID 102. So I'm going to do image ID is 102. And then I'm going to get the ROI IDs for this image. So I'm going to do ROI IDs is ezomero.get ROI IDs connection image ID. And of course, ROIs can only be at images, so we don't need to worry about giving what kind of object this is in or whatever. And we can have a look at those. And yes, we drew two ROI, so we get two IDs. Okay. Now, because a single ROI can have multiple shapes, we need to get the shape IDs that belongs to a specific ROI. So I'm going to get ezomero.get shape IDs, and that's going to be connection, and then I'm going to pick the first ROI ID here. You can pick the second one or any of the ones you've decided to do there. So you can just have a look at this, and it's going to be a single shape. And most of the time, if you're if all your ROIs in the server are single shape ROIs, which are 99.9% of them, normally the shape ID is going to be the same as the ROI ID, but you should not trust that. You should always actually get the shape IDs from an ROI. So in this case here, ROI 51 has shape 51 as most of the time. Okay, so now we can actually get the shape itself. So I can do shape is get shape, and I can just give it the ID for that shape. And actually, if you look at the documentation for get shape, well, it should be ezomero.get shape to begin with, you will see that this doesn't return only the shape, it returns the shape and then information about the stroke color, the fill color, and the stroke width. So actually this will return three more things here. I'm going to call it C1, C2, and stroke width. So now if I print the shape itself, you will see that this should be a rectangle if I remember right. Yeah, and if you want to look at the other things, you can I can show them to you. So this is just the color of the line around the ROI, the color that this is filled in the ROI, or vice versa. I don't remember the order of these, and the width of the line around the ROI. So you see that the main thing you get here is that you get an object that is an ezomero object. So it's a class in ezomero called rectangle. And this will have different properties depending on what kind of shape it is. So a rectangle, for example, has an X, Y, width, and height. Of course, if you have a line, for example, it's going to have 2 points. And these are all properties of this shape object. So if I do, for example, shape.x, I should just get the integer that is the X position for that rectangle. So it's pretty easy to get a shape from ezomero, and if you want to do statistics on their positions, for example, it's pretty easy to do. Here, of course, you're getting 4 different things being returned. If you don't like this form of writing things, you can also just do something like result is ezomero.getShape. You know what? Let me just copy paste this. And actually, let's pick the first one instead of the... And you see that if I print result, what happened? Oh, of course, there's only one shape ID. There are 2 ROIs, but for that ROI, there's only one shape ID. So you see, we got a tuple, which is a type of thing in Python. So if you wanted, for example, the X value for that rectangle, you would need to do something like this. So, you know, up to you what you prefer to do. I like getting things in different variables here, but yeah, up to you. Okay, so now we will try to do the opposite. We are going to create a shape. We're going to pass it via ezomero to the server and add it to our image. So just for fun, let's try an ellipse, which is something I have not drawn. So first thing you need to do is you need to import the ellipse class from ezomero.rois. So ezomero.rois has a fairly big variety of kinds of ROIs you can have. And then I'm going to create a shape here, which is going to be an ellipse. And I'm going to put it at 30 pixels X, 40 pixels Y, 10 pixels for the first axis, 20 pixels for the second axis. I'm going to give it a label, a new ellipse, and I think that's all I need. Yeah. So an ellipse in this case has X, Y, first axis, second axis. So the things you're going to give are going to change depending on what kind of ROI you're doing, of course. Okay, so now I can do new ROI ID, ezomero, post ROI. That's going to take a connection, an image ID, and it's going to take a list of shapes because you can have multiple shapes for a single ROI, as I mentioned multiple times now. But yeah, in this case, because we only have one shape for that ROI, it still needs to be encased into a list because we need to pass a list. But that's all you need to do. So, and then I'm actually going to print the new ROI ID. So we should have a new ROI with ID 53 that should be on our random image. So the first thing I'm going to do is I'm going to refresh this, and you'll see that the ROI count is now 3. And now I can open it, and you will see that there's a new ellipse here with the label I gave it and with the position x30, y40, radius x10, radius y20, which is exactly what we gave it. And that's it. That's all you need to do to create an ROI onto your image using ezomero. So you create a shape, you pass a list of shapes to post ROI. As usual, don't forget to close your connection. Your system admin appreciates it. Okay, so this is supposed to be a pretty introductory workshop to ezomero and the things you can do with ezomero. I hope it's been both enjoyable and useful. And as I said, feel free to reach out to us if you have any questions, if you have suggestions, if you want to contribute. We are completely open to people bringing their own ideas and influences to this project. There will be a Q&A session. I think it's now scheduled to be the 9th, but don't quote me on that. Check the website. So if you have any questions that came up during this workshop that you would like to have answered, please show up and come ask them in a synchronous way instead of this completely asynchronous workshop. Yeah, other than that, thank you for watching. Thank you for sparing me about an hour of your time and attention to look at this. We think it's super useful, and we think it's a really cool project. We hope other people think that as well. Yeah, I hope to see you at the Q&A. Yeah, see you next time. Bye-bye.